Okay, so today we're gonna look at using Matlab to do plots. So in Excel, you're accustomed with just having columns, and basically you plot column A versus column B, whatever, right? But in Matlab, instead of creating columns with values, we could just have the equation calculate the values first, and then we plot the values. So for example, if we have, let's say x equal to 1, 2, 3, 4, and we have y is equal to same thing 1, 2, 3, 4. Then we could simply say plot x versus y. Right, so remember at the beginning here, we always try to clear our screen and we invoke clear all to clean the workspace up. So when you do this now and you click run, you will get basic XY plot. Right, so that is basically how it is. It's pretty simple. We could say, okay, that's y2 equal to some equation 2 multiplied by x, and then we could say, okay, that plot, we could remove this from here by y. So we plot y2 instead of y. So you could see here. Okay, so that is plotting. If it is you want to get, you want to do a multiplication of a, or let's say an operation of an element inside a vector or array, you could say, okay, y3 is equal to, well, you want it to be, let's say we want x squared. So instead of putting x to the power square, what it will do, it will square the vector. That might work, but to be sure, we put a dot, and the dot tells Matlab that we want to do an operation on each individual element. So when we put x dot and we put to the power 2, what it does, it squares now each term. It squares 1, it squares 2, and creates a vector for y3. That is the square of each individual terms inside the x vector. So if we click run, you could see here, well, we still have y2 over here, so we change this to y3. We click run. So you could see now we are plotting against the x squared value. Right, so that is plotting in a nutshell. Right now, we may want to now expand this and have some titles, some legends, etc. So we could put here x label, open bracket, and then we put what the x label is. Right, this is x value or whatever, right? And we could put y label. Right, so remember we need to put our inverted commas. I remove this space here. So when you click run now, you could see we have some labels on the axis. We could also put now a title. Right, so we have a title. Right, so if we want to change the color or stuff, we could put after you put y3 now, then we could actually start affecting the change of how the plot looks. So we could put comma, and then we could put, let's say we want a color black. Now to get all these colors, you could actually, in the help file, type in plot, or you could, might be faster to actually go on the web, go up on your browser, on your browser page, and actually search, Google search plot in Matlab. So that is actually faster than sometimes using the files, the help files in Matlab itself. So with that, you could have a look here and see. So I just Google plot in Matlab, and this is what shows up. Right, so it basically goes through how to do plots in Matlab to get different configurations. So it's pretty straightforward. Right, it goes through how to get different lines and markers and stuff. So you could see here after you have your plot, you could put in your inverted commas, you could put 2 dashes, which should mean that you actually want one of the lines to be a dash. Right, so we're looking at a different color. So we come down to the end here and you could see, okay, for different colors. So for MATLAB, black is K, red is R, green is G, etc. So if we want a blue line, we could put inverted commas B. So we could come here and say, okay, inverted commas B. So that is telling MATLAB we want a blue line. So when you click run, see the line is blue. Right, if you wanted it black, it's black. If you wanted it black dash line, you could put two dashes after it, and it become dash. Right? Now the next line here, the next input could be line weight. So if you want the line thicker than what it is there, than the default, type line width. Right, so again inverted commas here. Tell MATLAB what it is you want, comma, and if we want a line width of 3, check it so a secondary line becomes there. Right, so we could keep it as 2 for now. It was a little thicker than the default. Right, so if we look at the plot itself that we need to recreate, you could see here that is white. Right, now the reason why I say white is that if you click on when you create the figure, you would see that if you were to export this, you will get a gray background. Right, so we need to get that to be a white background, because if you want to put it on a document, then we want it to be as transparent as it is. Right, so you can notice here now that it is actually white and not gray. Okay, so on to plotting the actual plot we need to recreate. Now we're only interested in the gigapascal side. We're not interested in the PSI side. Right, so for this we could say, okay, that our fiber volume is equal to, we go from 0, right, we want to go in increments of 0.1 all the way up to 1. Right, so as our fiber volume, it goes from 0 to 1, but we want to go in increments. Here it has 0.2, 0.4, so you could do like that also. It doesn't matter, we use Matlab doing the calculations. So 0.1, 0.2, 0.3, 0.4, etc. Right, so we created this now a vector of 0 to 1 with in 0.1 increments. So that's what we did here. Right, we know that Vm is really 1 minus Vf. Okay, so we know that, I'll just write it out here. Vm is equal to 1 minus Vf. Right, because that's the volume fraction of the matrix. Now, we cannot put 1 minus and then we have a vector here, or an array here. We need to now create something like an array of ones alone. So we could have 1 minus 0, 1 minus 0.1, 1 minus 0.2, 1 minus 0.3, etc. Right, so to do that, we say, okay, in MATLAB, we could create a vector of ones. We simply say O-N-E-S, ones. And what is the size of this vector? Well, what I'll do before I go into this, I'll just show you here. Right, so this vector, when you actually click run, it looks like this. Right, 0, 0.1, 0.2, 0.3, etc. So it goes straight across the line. Right, so we need to create a vector or an array of ones now, similar to this dimension. So when we say 1 minus Vf, it will actually minus 1 from 0, then 1 from 0.1, 1 from 0.2, etc. So what we do here now, we say, okay, we have one row, right? And we want to have, let's say we want 6 ones. Right, so if you click run here, you could see VM now is 1, 1, 1, 1. So we have 6 ones. Right, but and actually now we need to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We actually need 11. Right, so we could put 11 here.
We click run. So we actually have a 1 to minus each element. Or, that's one way, or you could say, okay, we could say 1 minus, and just to show you what I'm going to put next, the term length, or the piece of code length, tells Matlab that we want to find the length of a vector, meaning that how many elements are there. So if we put VF here, what we're saying is that we're asking Matlab, what is the length of this VF array or vector? When you click enter, you see it will tell us 11. So instead of typing 11 over here, and then later on we may come and change this to 0.2, for example, then we'll have to go back and count it over. So instead of doing that, we could put leng length VF. So whatever the length of VF is, it will actually pull that in this row over here. So that now when we actually run this now, we would see we actually have 11 ones. So it'll be 1 minus 0, 1 minus 0.1, 1 minus 0.2, etc. Right, so for example, if we change this to 0.2, well, of course, the length of the vector will decrease. So we have the accompanying length of VM. Right, so that's the point of doing all these things in code and Matlab. So it kind of automates the process. Right, so the next thing we want to do now is actually do a calculation. We want to say, well, this is VM, right? So this is VM. So we need to now minus now VF. Right, because we said VM is equal to 1 minus VF. So now we have the 1s minus VF, so that will give us VM. Next we want to do is define EF. Alright, so EF, according to the book here, is 410 GPA. Right, so we could actually put that in here. 410, and GPA is 10 to the power 9, so E to the power 9. Modulus of elasticity of the matrix, it was 4.1 GPA, so we will go with 4.1 E to the power 9. And we know that the longitudinal modulus of elasticity of the entire composite is now EF times VF plus EM times VM. Right, so this equation here, right, for the longitudinal direction. So now we could actually do our plot now. But before that, we could actually just click run just to make sure things are happening, and we could see we have the EL, EF, so we have the EL being calculated. So we could start off and say, okay, plot now VF versus EL. Just to make sure we get any straight line, that equation is working, right? Right, but if we look at the plot now, the plot was in GPA. Right, so it's nice and neat GPA. So we say, okay, EL now, to get this back to GPA, we could divide this, or we could multiply by 1 over 1 e to the power 9. Right, so you could do it in this line here, or you could do it here. Right, so that gives us in GPA. So if you were to run, so you could see now we have it in GPA. Right, so every time you make a run, you close off the figure. So that every time it runs, it will update and give you a new figure. Right, so the next thing we want to put now is, as we say, we want the color black. And then we want to define our line weight. Two. Right, so make sure, always ensure that you know you have the color purple. That will kind of close. So if you're missing out, it will look red like that. Right, so if you run this, so you can see we kind of get in there to our final plot. Right, the next thing we want to do is, well, if you look at this, it starts from, well, it goes from 0, so that's good. Right. So the next thing now we want to do is set our labels. So we can go X label, right? And the label was for the X axis was fiber volume fraction, comma VF. So you can put on caps lock, fiber volume fraction V. Now to get a subscript, we hit the underscore button and F. Close bracket. Right, so the subscript will give us the underscore give us a subscript. So that's how we end up with the subscript F here. For the Y label, the Y label was subscript L and then open bracket G P. Those were our units. So if you run again, we could see we have that here. Alright, so the next thing we want to do is we want to make the color, um, you want to make the background white. Alright, so this is GCF. Alright, so the background is now white. And then we could put our title. Alright, so if you want the grid, for example, if you want lines on the graph, you could simply type grid on. Alright, so we actually get the grids now. Alright, so the next thing that asks for, well, the next thing we're looking at is we have some text here. So how can we put in this text? Alright, so we look at the plot and we say, okay, we want the text to be around here. So starting at like maybe 0.5 or so. Right, so our coordinates for the text will be like maybe 0.5 by 100 or 120, for example. Right, so we could actually create now, we could say text or anything you want to put, you could put plot text if you want, anything you want to label it as. And then you open bracket and you actually type out the text you want. Alright, so it's boron e epoxy data. Right, so that is one line. So we go comma to get to the next line. Alright, so E underscore F. Right, and then next line now, E. Right, so that is the text we want to get. And to actually get the text on it, the plot, we go TEX as the command text. And we said it was about 0.5, 100. Right, so those were that actually is the coordinates. Now you want your text box to start from or whatever, where you want to start placing your text. And it was plot underscore text. Right, so that was the name of the variable we created. So when you run this now, right, so there's an error message, right? Invalid plus colon. Use. Alright, so somewhere line 16, missing a bracket somewhere. Alright, so the error somewhere has to do with this over here. Alright, so it could be the fact that we use wrong brackets, so you may have to use curly brackets here. Now again, when you go on you do a Google search, you could search text on Matlab plot, for example. The community is so big that, and you will see the solution. So the solution for this probably could be use the wrong type of bracket. It needs to be curly bracket. So I'll run it and see. Right. So it was the curly bracket. So we have the two lines here. So you could see it started as 0.5. The middle the line here is at 100. Right. So in terms of our plot here now, well, it would be nice if we could put in the equation. So what we could do, that could be a separate line here. So we could come here, comma, and we could actually put in the equation. It was E underscore F multiplied by V. Right, so because we type in this text, right, not actual formulas, we could actually put I just want it here. We could actually just have it side by side. So EF VF, right, because it's not an actual equation, there's no need to put a multiplication symbol. Right, so plus now E underscore M V underscore M. This is common M. Right, so we have the equation underneath here. Right, so our senior EL is equal to that. That's actually supposed to be EM. Alright, so to export this, you could click save here, you could go file, save as, and you could actually save it. Let's say save it here. Alright, so if you actually when you open it now, you could see it's a nice neat plot. And you can actually copy and paste this now into your documents, into your write-up file, for whatever. And so that is why we use Matlab over Excel when we're doing plots, because it's quick to make adjustments. You don't have to keep right-clicking and adjust parameters and line thicknesses. It's actually set up such that for engineers and scientists in mind, knowing that how we actually do our plots. You notice the text is already to scale. We don't have to change the size of the, you could if you want, but the default is such that it gives us very quickly the plots that we require for our write-up, for whatever it is we're doing. So all these texts that you would see in textbooks and stuff, they would have been from Matlab, more than likely. I'd say you could come after and you could copy and paste a little image inside if you want. I saw all this thing could happen in post production kind of things. Alright, so what I want to show now is with that covered, and as you know for the exercise, suppose you want to get things like sigma and epsilon and those type of Greek letters. Alright, so one way to do that, you could actually, so what I'll do, I'll just copy and paste this so we wouldn't mess with this. Alright, and then I will just comment this out, meaning that the Matlab wouldn't run this, then it will run this one. Alright, so if you want to change, for example, we want to have sigma. We want to have sigma x, for example. Right? Sigma is that's just symbol for stress, right? But if you write sigma, what will happen is that it will actually write sigma below here. Right? So we want Matlab to know is our Greek letter. So what we do here is we put our backslash. So the backslash tells Matlab that we're talking about Greek letters. So when you click run now, you can see you have the sigma symbol here now. Right? So you could put sigma x, for example, and you have sigma x. Right, so your names for all the different types of Greek letters you could get again on the help file. You Google Greek letters plot, for example, and you will get all the symbols for Greek letters. Right, so for example, if you want to have let's say sigma x and um, epsilon y. So you see sigma x and epsilon y over here. So that's how you get Greek letters.